Picture this. It's 1938 and you walk into a British motor show where gleaming steel V8s are making 300 horsepower, chrome everywhere, engines the size of refrigerators, frames built like battleships. Then you see it, a car with a wooden skeleton, an engine making 35 horsepower, and a design that looked like someone had given up halfway through. Everyone laughed until owners started reporting 500,000 miles on the same engine with the same wooden frame, still running. The setup, Detroit's steel monsters versus Morgan's wooden toy. Let me set the scene for you. 1938. The automotive world had figured things out, or so they thought. You built cars with steel frames, heavy, rigid, strong. You needed big engines to push all that weight. Minimum 60 horsepower, preferably more. Suspension involved springs and dampers and configurations that required engineering degrees to understand. This was settled science. In America, Ford was churning out flathead V8s making 85 horsepower. Cadillac had introduced the V16 because apparently 8 cylinders weren't enough to prove you had money. Even the economy cars, the basic transportation appliances, had 45 to 50 horsepower and steel chassis that weighed as much as a small building. In Europe, things were slightly more restrained, but the philosophy was the same. Alfa Romeo was building all-steel race cars. Mercedes was perfecting the overhead cam straight six. Jaguar, still called SS cars back then, was laying the groundwork for their steel-frame sports cars. Everyone agreed on the fundamentals. Steel frame, substantial power, conventional suspension. Then there was Morgan Motor Company, still operating out of the same small factory in Malvern Link, England, where it had started in 1910. And HFS Morgan, the founder, had just done something that made every automotive engineer in Europe shake their heads in disbelief. He'd announced a four-wheeled car with a wooden frame, powered by an engine making 35 horsepower. 35. The Morgan 44, named because it had 4 wheels and 4 cylinders. A naming convention so simple it was almost insulting. The specs read like a joke. Wooden ash frame, like a piece of furniture on wheels. Coventry Climax engine producing 35 brake horsepower, less than most motorcycles. Independent front suspension using Morgan's weird sliding pillar design that looked like it had been invented by someone who'd never seen proper suspension before. Total weight, 1,300 pounds. Let that sink in, 1,300 pounds. A modern Miatas weigh twice that. Smart cars weigh more. This thing was basically a motorized go-kart pretending to be a proper automobile. The British automotive press was savage. Autocar magazine called it an interesting experiment in unconventional construction. Motorsport was more direct, suggesting that perhaps Morgan should stick to what they know, meaning three-wheelers. The established manufacturers didn't even bother commenting. A wooden car with 35 horsepower wasn't worth acknowledging. But here's where the story gets interesting. Because while everyone was laughing at the Morgan 44's specifications, nobody was paying attention to what those specifications actually meant in the real world. HFS Morgan, the maverick who refused to grow up. To understand why the 44 existed at all, you need to understand Henry Frederick Stanley Morgan, HFS to everyone who knew him, which tells you something right there. The guy insisted on initials because his full name sounded too formal. That should have been everyone's first clue that he wasn't going to build conventional cars. Morgan had been building three-wheeled cycle cars since 1910. These weren't cars in any traditional sense. They were motorcycle engines bolted to a minimalist frame with 3 wheels and a prayer. 2 wheels in front, 1 in back, no reverse gear, no weather protection worth mentioning. They were ridiculous. They were also incredibly successful. By 1930, Morgan had sold over 30,000 three-wheelers, 30,000 units of a vehicle that looked like it had been designed by someone who'd heard about cars but never actually seen one. They sold because they were cheap, fun, and nearly indestructible. You could crash a Morgan three-wheeler, hammer the frame back into shape, and keep driving. Try that with a steel chassis. But the three-wheeler market was dying. The British government had changed tax laws, eliminating the advantage three-wheelers had enjoyed. Customers wanted 4 wheels, HFS. Morgan needed to build a proper 4-wheeled car or go out of business. Here's where most companies would have done the sensible thing. Design a steel chassis, license a conventional engine, adopt standard suspension, become like everyone else. not HFS Morgan. This man looked at the entire automotive industry, at decades of accumulated engineering knowledge, and essentially said, what if everyone is wrong? His reasoning was beautifully simple and completely insane. Steel frames were heavy, expensive to repair, and corroded. Wood, specifically English ash, was light, easy to work with, and if properly maintained, would last indefinitely. Steel frames were rigid, which meant they transferred every bump and shock to the passengers and components. Wood had natural flexibility, acting as part of the suspension system. Morgan's engineers, and by engineers, I mean the handful of craftsmen who actually built these things, thought he'd lost his mind. You can't build a car frame from wood. It's not done. It's not safe. It won't last. Morgan's response was to point at his three-wheelers, which had wooden frames and had been running for decades with minimal maintenance. The sliding pillar suspension was another Morgan peculiarity carried over from the three-wheelers. Instead of conventional coil springs and dampers, the Morgan used a vertical pillar that slid in a tube, with springs providing resistance. It looked primitive. It looked like something from the 19th century. It was also incredibly effective, providing a smooth ride and virtually no maintenance requirements. No ball joints to wear out, no complex geometries to get out of alignment, just a pillar sliding up and down. For the engine, Morgan didn't build his own. He never had. He bought Coventry Climax units, small four-cylinder engines designed for industrial use. The one chosen for the 4.4 produced 35 brake horsepower at 4,500 RPM. In 1938, this was embarrassing. Ford's flathead V8, available in the cheapest model 48, made more than twice that. But Morgan understood something the big manufacturers had forgotten: power-to-weight ratio. That 1,300-pound Morgan 4.4, with its pitiful 35 horsepower, had a power-to-weight ratio of 37 pounds per horsepower. A Ford V8, with its 3,000-pound curb weight and 85 horsepower, had 35 pounds per horsepower. The Morgan was actually faster. The first 4.4 rolled out of the Malvern factory in 1936. Morgan built them by hand, one at a time, using traditional coach building techniques. The ash frame was steam bent and joined with mortise and tenon joints like furniture. The aluminum body panels were hammered over wooden forms. Each car took weeks to build. There was no assembly line, no interchangeable parts, no mass production. It was automotive manufacturing as it had been done in 1900, not 1936. The price was £198. For context, a Morris 8, the cheapest mass-produced British car, cost £120. So you were paying 65% more for a car that had less power, no steel frame, and was built by hand in a barn. The Morgan should have been a complete failure. The laughable specifications that somehow worked. Let's talk about that engine, because the Coventry Climax unit in the 4.4 deserves its own discussion. 35 horsepower from a 1052 cubic centimeter four-cylinder engine. That's 1.08 horsepower per cubic inch. Modern engines make 3 times that. Hell, my lawnmower makes more power per displacement. The engine was side valve, meaning the valves were next to the cylinders, not overhead. This was already outdated technology by 1938. Overhead valve engines were the future. Everyone knew this. Side valve meant poor breathing, low compression ratios, limited RPM capability. The Coventry Climax had a compression ratio of 6.2 to 1, 6.2. Modern engines run 10 to 1 or higher. The carburetor was a single Solex unit, a simple downdraft design that fed all 4 cylinders through a single intake manifold. No twin carbs, no forced induction, no electronic management because electronics didn't exist yet. Just a simple carburetor that occasionally needed adjustment, and that was it. The transmission was a 4-speed Meadows gearbox, all synchro mesh. This was actually advanced for 1938. Many cars still had crash boxes that required double clutching, but the ratios were absurdly tall. First gear was only good for starting. Second got you to 25 miles per hour, third to 45, and fourth was an overdrive that the engine could barely pull. Now the frame. No, the frame. This is where things get really interesting, and where everyone thought Morgan had completely lost the plot. The main structural element was ash wood, the same material used for tool handles and baseball bats. Long, straight-grained pieces were steam-bent into curves, then assembled with traditional mortise and tenon joints. The joints were pinned with steel bolts and bonded with marine-grade glue. On top of this wooden skeleton, they bolted steel brackets and mounting points for the suspension and drivetrain. The engine sat on steel mounts attached to wooden frame members. The rear axle was located by steel arms attached to wooden cross members. It was a hybrid system. Wood for the main structure, steel for the highly stressed mounting points. The body was all aluminum, hand-formed over wooden bucks. No two bodies were exactly identical because they were made by craftsmen, not stamped by machines. Panel gaps varied. Fit and finish was inconsistent, but the aluminum wouldn't rust and was easy to repair. Dent a panel, hammer it back out. Tear a panel, replace just that section, not the entire body. The suspension, that weird sliding pillar front end, was pure Morgan. Each front wheel had its own vertical pillar that slid up and down in a cast bronze bushing. Coil springs provided resistance, and basic friction dampers controlled oscillation. It looked agricultural. It looked like something from a tractor. It also provided an incredibly smooth ride and could handle terrible roads without drama. The rear suspension was a solid axle on semi-elliptic leaf springs. Basic, unsophisticated, exactly what you'd find on a cheap economy car. But remember, the whole vehicle weighed 1,300 pounds. The rear springs didn't have much work to do. Brakes were mechanical drums all around, cable operated. No hydraulics because hydraulics were complicated and expensive. Pull the brake lever, cables pulled the brake shoes against the drums, the car stopped. Simple, reliable, easy to adjust. The steering was unassisted, obviously. Power steering wouldn't become common for another 2 decades, but with 1,300 pounds to maneuver, you didn't need assistance. The steering ratio was quick, giving the Morgan surprising agility. The whole package, this wooden-framed, aluminum-bodied, 35-horsepower Curiosity, could hit 75 miles per hour on a good day with a tailwind. 0 to 60 took around 22 seconds. 22 seconds. Modern Priuses are faster, but fuel economy was nearly 40 miles per gallon, which in 1938 was extraordinary. Here's what the automotive press said when they first tested the 4.4. The Motor Magazine wrote, "The Morgan offers an interesting study in alternative construction methods, though we question its long-term viability." Translation: "It's weird and probably won't last." Autocar said, "For those willing to accept its eccentricities, the Morgan offers sprightly performance." Translation: "It's fast for what it is, but it's still weird." Nobody, and I mean nobody, predicted what would actually happen. Because while automotive journalists were writing polite reviews questioning the wooden frame's durability, early Morgan owners were discovering something extraordinary. The first shocks. When Wood started winning. The first Morgan 4.4s went to enthusiasts, people who didn't care about convention and wanted something different. Sports car club members, amateur racers, engineering professors who appreciated the design's simplicity. These weren't normal car buyers. They were people who understood what they were getting into. And then reports started coming back to the factory, reports that made no sense. Owners were writing letters describing 10,000 miles without any mechanical issues. Then 20,000, then 50,000, 50. These were wooden frame cars with tiny engines and primitive specifications. They should have been falling apart. A doctor in Yorkshire bought a 4.4 in late 1936. By 1939, he'd put 70,000 miles on it. His report to Morgan stated that he'd done nothing but oil changes and brake adjustments. The wooden frame showed no signs of deterioration. The engine was running perfectly. He was averaging 38 miles per gallon. A racing enthusiast in Sussex began campaigning his 4.4 in club events. Lightweight and decent handling made it competitive against cars with twice the power. He finished in the top 3 in 12 consecutive club races, defeating MGs, Singers, and other proper sports cars. His secret wasn't skill, it was weight. While everyone else was hauling around 3,000 pounds of steel and cast iron, he was pushing 1,300 pounds of wood and aluminum. By 1939, 3 years after introduction, Morgan had a waiting list. Not a small waiting list, a 2-year waiting list. People were ordering cars they wouldn't receive until 1941. This had never happened with the three-wheelers. The 4.4, the car everyone had mocked, was becoming a phenomenon. Then World War II happened and civilian car production stopped. The Malvern factory was converted to manufacturing parts for aircraft. The 4.4 production line went silent. But here's where the story gets really interesting. Those pre-war 4.4s that had been sold, the ones everyone expected to rot away or break down, kept running through the war, kept running through post-war austerity, kept running through the 1950s. There's a 4.4, chassis number 341, sold in 1937 to a traveling salesman in Cornwall. This man drove it constantly. Terrible roads, all weather, minimal maintenance during wartime restrictions. By 1950, he'd logged 140,000 miles. The wooden frame was fine. The engine had been rebuilt once. The body was dented but solid. He wrote to Morgan asking if they wanted the car back for study. They did. When Morgan's engineers examined chassis 341, they found something that contradicted everything they had been taught about automotive engineering. The wooden frame members showed wear, yes, but no structural degradation. The flexibility of wood had actually protected the frame from stress cracks. Where a steel frame would have developed fatigue failures, the wood had simply flexed and absorbed the shocks. The joints, those mortise and tenon connections everyone said would loosen and fail, were still tight. The marine glue had done its job. The steel bolts showed minimal wear. An engineer from Austin Motor Company, visiting Morgan on unrelated business, examined the frame and reportedly said, "This shouldn't work," but obviously it does. After the war, production resumed. Morgan built 4.4s exactly as they had before. Same wooden frame, same 35 horsepower Coventry Climax engine, same hand-built construction. Nothing had changed. They could have modernized, adopted steel frames, increased production volume. They didn't. HFS Morgan, still running the company, saw no reason to change what worked. By the early 1950s, something remarkable was happening. Those pre-war 4.4s were hitting 200,000 miles, then 300,000. Owners were reporting minimal maintenance, mostly replacing wear items like brakes and clutches. The engines, those pathetic 35 horsepower Coventry Climax units, were still running. The wooden frames were still solid. A 4.4 owner in Scotland, a shepherd who used his car for remote farm visits, reported 320,000 miles in 1953. His maintenance log, which he sent to Morgan unsolicited, showed oil changes every 2,000 miles and basically nothing else. He'd replaced the clutch once and the brakes twice. That was it. Then in 1954, the story broke. A newspaper in London ran an article about a Morgan 4.4 that had exceeded 500,000 miles. 500,000. The owner, a sales representative who'd bought the car new in 1937, had documentation for every mile. Oil change receipts, repair records, everything. In 17 years, he'd circled the earth 20 times. In a wooden car with 35 horsepower, the automotive establishment was forced to pay attention. How was this possible? Wood was supposed to rot, warp, and fail. Small displacement engines were supposed to wear out quickly. Hand-built cars were supposed to be unreliable because precision was impossible without machinery. The Morgan 4.4 violated every principle of automotive engineering, yet it was achieving reliability numbers that shamed mass-produced steel cars. The engineering truth: why wood outlasted steel. Here's what engineers eventually figured out, though it took them embarrassingly long. The wooden frame wasn't a weakness, it was a massive advantage. Steel frames are rigid. This seems like a good thing until you understand what rigidity means. When a steel frame encounters stress, whether from road impacts, cornering forces, or simple age, it concentrates that stress at specific points, usually at welds or mounting points. Over time, these stress concentrations develop into cracks, fatigue failures. Once a steel frame cracks, it's done. You can weld it, but the repair is never as strong as the original material. Wood doesn't work that way. Wood is flexible at the cellular level. When stress is applied, the wood fibers compress slightly, absorbing the energy. When the stress is removed, the fibers return to their original position. This happens millions of times over the life of the car. Each bump, each pothole, each hard corner gets absorbed by the wood's natural flexibility. The Morgan's ash frame was essentially acting as a secondary suspension system. The sliding pillar front suspension handled large impacts. The wooden frame absorbed everything else. Passengers reported that Morgans rode smoother than heavier, more sophisticated cars. Now we know why. The entire structure was flexing microscopically with every road irregularity. But what about rot? Wood rots. Everyone knows this. Except properly maintained ash doesn't, not for decades. The Morgan frame members were treated with linseed oil, which penetrated the wood fibers and excluded moisture. The factory recommended that owners treat the frame annually. Most did, because it took about an hour and cost almost nothing. Where steel frames needed expensive rust prevention treatments and still corroded, wooden frames needed a coat of linseed oil. Where steel frames could hide rust inside hollow sections, wooden frames showed any deterioration immediately. An owner could visually inspect the entire frame in minutes. Repairs told the whole story. Damage a steel frame member, and you're talking about cutting, welding, and refinishing. Requires specialized equipment and expertise. Damage a wooden frame member, and any decent woodworker could fabricate a replacement in an afternoon. The repair would be as strong as the original because wood doesn't have a heat-affected zone like welded steel. Several 4.4 owners reported doing frame member replacements themselves in their home workshops. One owner in Wales documented replacing a front cross member that had been damaged in a collision. Total time, including shaping the new piece, steaming it to the correct curve, and installation, was 6 hours. Total cost, a piece of ash and some glue. Try that with a steel frame. The weight advantage compounded everything. At 1,300 pounds, the 4.4 put minimal stress on every component. The 35 horsepower engine wasn't straining to move the car. The brakes didn't have to dissipate massive amounts of energy. The suspension wasn't being pounded into submission by a heavy vehicle. Think about it this way. A 1938 Ford V8 weighed 3,000 pounds and made 85 horsepower. That's 35 pounds per horsepower. But the Ford's engine was working hard to move that mass. Hard work means heat, wear, and failures. The Morgan's engine, moving 1,300 pounds with 35 horsepower, was loafing along. It never worked hard enough to stress itself. The Coventry Climax engine in the 4.4 typically turned around 3,000 RPM at cruising speed. That's gentle operation for an engine designed to peak at 4,500 RPM. The engine was spending its entire life in the middle of its power band, the most efficient region. No lugging at low RPMs, no screaming at high RPMs, just constant moderate operation that minimized wear. Engineers from other manufacturers who studied the Morgan in the 50s came away shaking their heads. The car shouldn't work. It violated established principles, but it did work, and it worked better than their sophisticated, expensive, scientifically designed vehicles. One engineer from Rover, speaking privately to colleagues, supposedly said, "The Morgan proves that sometimes primitive engineering is the most advanced engineering. We've been optimizing the wrong variables." The establishment's confusion and fury. Detroit and the big British manufacturers had a problem. The Morgan 4.4 was making them look stupid. Here they were, spending millions on research and development, employing thousands of engineers, operating massive factories with the latest equipment. And they were being embarrassed by a small company in Malvern that hand-built cars with wooden frames and off-the-shelf engines. The first response was denial. The Morgan was a niche product, a novelty. It would never sell in serious numbers. Real car buyers wanted steel frames and real power. The Morgan would fade away. Except, it didn't fade away. Waiting lists grew longer. By the late 50s, you ordered a Morgan and received it 3 years later. Then came the attempts to replicate Morgan's success. Several British manufacturers considered wooden frame construction. They ran the numbers, did cost analyses, and concluded it couldn't work at scale, which was technically true. Morgan's business model only worked because they built 20 cars per week and had customers willing to wait years. Mass production required steel and automation. Some companies tried to compete on weight, build lighter steel frames, use aluminum bodies, chase that power-to-weight ratio. Every attempt resulted in cars that were expensive, fragile, or both. Turns out, you can't just make steel frames lighter without sacrificing strength. The engineering trade-offs were brutal. A few manufacturers looked at the Morgan's longevity and tried to understand it. Austin Motor Company supposedly bought a high-mileage 4.4 in the mid-50s and had their engineers tear it down completely. Their report, never published externally, concluded that the wooden frame's flexibility was key to longevity, but they couldn't figure out how to market wooden frames to the public. Flexible steel frame sounded good. Wooden frame, like your furniture, sounded terrible. The racing establishment had its own Morgan problem. These little wooden cars kept winning class championships. Not overall victories, the 35 horsepower engine prevented that. But in under 1200cc classes, Morgans dominated. The combination of lightweight and good handling overcame the power deficit. Sports car clubs started creating special rules to limit Morgan advantages. Some classes set minimum weight requirements that conveniently excluded the 4.4. Others required steel frames. The Morgan response was to simply race in different classes and keep winning. By the 1960s, the automotive world had split into two camps regarding Morgan. One camp dismissed them as anachronistic curiosities that proved nothing about modern automotive engineering. The other camp quietly admitted that maybe, just maybe, Morgan had figured something out that everyone else had missed. The waiting list phenomenon baffled business analysts. Morgan built about 1,000 cars per year. They had orders for 3,000. Basic economics said they should increase production, right? HFS. Morgan's response was that building more cars would require compromising quality, and he wouldn't do that. He'd rather have a waiting list than build inferior cars. This attitude drove mainstream manufacturers crazy. You don't artificially limit production. You don't make customers wait years for a product. You scale up, maximize profits, and drive competitors out of business. That's how you win. Except Morgan was winning by doing the exact opposite. The impossible legacy still wouldn't. After 8 decades. Here's the part that should break your brain. Morgan still builds the 4.4 today. Well, technically it's called the +4 now, and there have been continuous improvements over 85 years. But the fundamental design, wooden ash frame, independent front suspension, hand-built aluminum body is unchanged. You can walk into a Morgan dealer today and order a car that's built the same way they built them in 1938. The frame is still steam-bent ash with mortise and tenon joints. The body is still hand-formed aluminum. Each car still takes weeks to build. There's still a waiting list. The collector market for early 4.4s is insane. A well-preserved 1930s example can sell for 60,000 pounds or more. But here's what's really crazy. Those cars aren't just collector items sitting in climate-controlled garages. People actually drive them. There are 4.4s from the 1930s that are still being used as daily transportation. There's a 4.4 in New Zealand, chassis number 211, built in 1937. Current owner bought it in 2008 with 430,000 documented miles. He's added another 80,000. The wooden frame is original. It's been maintained obviously with periodic treatment and one frame member replacement in 1972, but it's still fundamentally the same structure that left the factory 87 years ago. Think about that. A wooden car frame that's been in continuous use for nearly 90 years. How many steel cars from 1937 are still drivable? How many are still on the road doing their actual job of transporting people? Modern Morgan buyers, and yes, there are modern Morgan buyers, choose the car for exactly the reasons people bought them in 1938. They want something different, something that rejects mainstream automotive philosophy. They want a car that's simple, maintainable, and honest about what it is. The automotive press still doesn't quite know what to make of Morgan. Reviews inevitably mention that the car is anachronistic, outdated, and impractical. Then they admit it's charming, characterful, and somehow more enjoyable than modern cars, with 10 times the power and 100 times the technology. What Morgan proved, and what the industry still struggles to accept, is that optimization isn't always about maximizing performance or minimizing cost. Sometimes the optimal solution is the one that's simple, maintainable, and appropriate for its purpose. A wooden frame wasn't the most advanced technology in 1938, but it was the right technology for what Morgan was trying to build. The 500,000-mile 4.4s aren't anomalies. They're the norm for well-maintained examples. There are dozens of documented cases of 4.4s exceeding 300,000 miles with minimal repairs. This from a car that weighs 1,300 pounds and makes 35 horsepower. Modern cars are engineered for specific service lives. 150,000 miles is considered high mileage for most vehicles. Don't manufacturers design around this expectation? Everything is optimized for that lifespan, nothing more. The Morgan wasn't designed around a specific mileage target. It was designed to be maintained indefinitely. The wooden frame could be repaired or replaced. The engine could be rebuilt. The aluminum body could be reshaped. Nothing was meant to be disposable. This philosophy extended to the ownership experience. Morgan buyers weren't just buying a car. They were buying into a relationship with the company and with the product. You maintained your Morgan. You learned its quirks. You treated it as a tool that required care, like a musical instrument or a fine watch. The modern automotive industry has spent decades moving in the opposite direction. Cars are increasingly complex, sealed units that owners can't maintain themselves. Repair requires specialized tools and dealer-specific diagnostics. This creates dependency and recurring revenue for manufacturers. It also means cars become worthless when they're out of warranty because repair costs exceed vehicle value. Morgan never went down that path. You can still service a 1938 4.4 with basic hand tools. You can still order replacement parts for cars built 85 years ago. The company maintains the ability to manufacture any component for any Morgan ever built. This isn't profitable in a traditional sense, but it builds loyalty and reputation that money can't buy. The 1938 Morgan 4.4 was everything a car shouldn't be. Wooden frame in an age of steel. 35 horsepower when 50 was minimum. Hand-built when mass production was the future. It should have been a footnote, a curiosity, a dead-end experiment that proved why you don't make cars from wood. Instead, it became proof that the automotive establishment didn't know everything. That sometimes the simplest solution, the one that violates all the rules, is the one that actually works. That you can build a car from wood and have it last 500,000 miles. That 35 horsepower is enough if you're not trying to move 3,000 pounds of unnecessary steel. HFS Morgan never tried to compete with Detroit. He built what he wanted to build and found customers who wanted what he was building. No focus groups, no market research, no compromise. Just a stubborn Englishman who thought wood and aluminum could work as well as steel and cast iron. And you know what? He was right. 8 decades later, Morgan is still building wooden cars, still hand-forming aluminum bodies, still maintaining waiting lists. The 4.4 proved that different could work, that simple could beat sophisticated, that the underdog could win by refusing to play the establishment's game. Every time some engineer proclaims that something can't be done, remember the Morgan. Remember the car with a wooden frame and 35 horsepower that shocked everyone by outlasting everything else on the road. Sometimes the impossible just needs someone crazy enough to try it.